2025 A-Level Combined Mathematics Paper 1, Part B, Question number 15, Part C. Part A of this question was discussed in a previous video, link in the top right, and Part B of this question was also discussed in a previous video, link in the top right. Parts A, B and C of question number 15 all have to do with mathematical integration, but Part C usually has to do with some kind of special formula or identity that's related to mathematical integration that you have to use in order to find the final result of the question. So in this particular question, we have that using the formula that the integral from 0 up to a of f of x with respect to x is equal to the integral from 0 up to a of f of a minus x with respect to x, where a is a constant, we are asked to show that this integral on the left is equal to this integral on the right. Now if we take a look at the two integrals, we can see the first integral is the integral from 0 up to pi by 6, which is of the pattern the integral from 0 up to a of the cosine of x plus pi by 3 divided by the sine of x plus the cosine of x plus pi by 3 with respect to x, and that is supposedly equal to the integral from 0 up to pi by 6, which is matching again the form that we have here, but this time it is of sine of x divided by sine of x plus cosine of x plus pi by 3 with respect to x. Now we can see, interestingly, if we take a look at the numerators, adding the two numerators sine of x and cosine of x plus pi by 3, we get exactly the denominator, which is also sine of x plus cosine of x plus pi by 3. Now that particular result will be useful in finding the second answer here, but for the first result we only really need to use this formula and some trigonometric identities. So let's try and solve the first part and then use the result and the fact that the top parts added together is equal to denominator in order to find the second part. So for the first part, what we're going to have to do is to say, using the fact that we have the formula, the integral from 0 up to a of any function f of x with respect to x is equal to the integral from 0 up to a of f of a minus x with respect to x. Using this fact, if we consider the two integrals that we have up here, we can see the integral on the left is of the form 0 up to some value a of f of x, and we have to assume that if we apply this thing to this integral here, we will get this integral here, because they said using the formula show that. So let's try it and see what happens. So if we consider the left hand side is going to be this integral on the left here, which is the integral from 0 up to pi by 6 of all of this. So if we write that down, the integral from 0 up to pi by 6 of, if we go up, the cosine of x plus pi by 3 divided by sine x plus again cosine of x plus pi by 3, all integrated with respect to x, and we can see this is of the form of the integral from 0 up to some value a of f of x. Now using the formula above, we can see it's going to be equal to the integral from 0 up to a, which in this case is the integral from 0 up to pi by 6 of f of a minus x. Now in this case a is pi by 6, so we have f of pi by 6 minus x. Now in this case, what that means for this expression here is that we need to substitute every instance of x within this expression for an a minus x. So here in this case, since a is equal to pi by 6, we need to substitute this x with pi by 6 minus x, we need to substitute this x with pi by 6 minus x, and we need to substitute this x with pi by 6 minus x. So if we do that, if we rewrite the expression with that substitution, we can see we get on the top pi by 6 minus x plus pi by 3, and at the bottom we get the sine of pi by 6 minus x plus the cosine of pi by 6 minus x plus pi by 3, all integrated with respect to x. So all of this is being integrated with respect to x. Now if we consider what we have, we can see that some of these things can be simplified. For example, this pi by 6 and this pi by 3 can be added together to a single value. Similarly, this pi by 6 and this pi by 3 can be added to a single value. If we do that, we can see we have the integral from 0 up to pi by 6 of, and if we consider the inside, we have the cosine of, if we add these two together, we know pi by 6 plus pi by 3 is going to be pi by 6 plus 2 pi by 6, which is going to be 3 pi by 6, which is going to be pi by 2. So we have pi by 2 minus x. This is then divided by the sine of pi by 6 minus x, which for now I'm going to leave as pi by 6 minus x, plus again the cosine of pi by 2 minus x integrated with respect to x. Now at this point we're going to use the first trigonometric identity that we're going to be using here, which is the fact that the cosine of pi by 2 minus x is equal to the sine of x, and similarly the sine of pi by 2 minus x is equal to the cosine of x. So using that, using cosine of pi by 2 minus x equals sine x, we get, and actually I'm going to call this integral here I, because that will make it easy to transfer. Otherwise I have a equal sign that I'm carrying up to here, and then suddenly I don't have the equal sign anymore. So at this point I'm going to say I equals, and then substituting cosine of pi by 2 minus x as sine of x, we get the integral of 0 to pi by 6 of sine of x divided by sine of pi by 6 minus x plus sine of x integrated with respect to x. Now at this point, if we go up and consider the result that we wanted the integral from 0 up to pi by 6 of sine of x divided by sine of x plus cosine x plus dx, x plus pi by 3 with respect to x dx. But here what we have, we can see from what we have a sine of x divided by sine of x part is also there. So in this expression, this bit is there, but in the denominator, instead of cosine of x plus pi by 3, we have a sine of pi by 6 minus x. Now in order to convert this into a cosine of x plus pi by 3, what we're going to have to do is to add and subtract a pi by 2 from this. Because if we just do that, we'll see what happens. We get the integral from 0 up to pi by 6 of the sine of x divided by, and I'm actually going to take the sine of x to the other side. I'm going to take it to the left hand side, since that is how it's shown in the final answer. So we are going to have sine of x divided by sine of x plus this thing I'm going to rewrite as the sine of pi by 2 minus, and then the rest of it, which if you consider what we're going to have, if we add pi by 2 randomly, we're going to have to subtract pi by 2. So we have pi by 2, and then we have a pi by 6, which if we subtract is going to be inside of the minus is going to be a minus pi by 6, and then the minus x inside of the minus is going to be plus x. So we have this expression right here, and all of this is integrated with respect to x. Now if we consider what we have, we can see this part right here is the sine of pi by 2 minus an angle here. So therefore, since we know that the sine of pi by 2 minus anything is equal to cosine of that value, in this case, since we have the sine of pi by 2 minus this whole thing, we're going to have that this is equal to the cosine of this whole thing. So therefore, this is equal to the integral from 0 to pi by 6 of the sine of x divided by the sine of x plus, now if you consider what we have the cosine of the angle on the inside with respect to x, and the angle on the inside here is pi by 2 minus pi by 6 plus x, and as we know, pi by 2 minus pi by 6 is pi by 3. So we have pi by 3 plus x, which I'm going to write as x plus pi by 3. Now at this point we can clearly see this is exactly what we wanted in our question. We wanted the integral from 0 up to pi by 6 of sine of x divided by sine of x plus the cosine of pi by x plus pi by 3 with respect to x, which is exactly what we have here. So we can see we got our final result starting only from the initial result on the left hand side. So starting from the left hand side, we go to the right hand side, which means that the left hand side and right hand side are equal. So as a conclusion, we could say in the next line, therefore the integral from 0 to pi by 6 of the cosine of x plus pi by 3, x plus pi by 3 divided by sine of x plus the cosine of x plus pi by 3 integrated with respect to x is equal to the integral from 0 up to pi by 6 of what we had earlier, which is the sine of x divided by the sine of x plus cosine of x plus pi by 3, all integrated with respect to x. So there we go, we have derived that part of our result. Now for the second part, as I hinted, we're going to need to use the first part's result. If we consider what we have that we are supposed to deduce that the integral from 0 to pi by 6 of this thing right here, which is this exact integral, is equal to pi by 12. Now if we consider the double of this value, if we consider 2i, as in consider 2i, which is going to be equal to double the integral from 0 to pi by 6 of the cosine of x plus pi by 3 divided by sine of x plus cosine of x plus pi by 3 with respect to x. Since above we know that this integral is equal to this integral, we can see if we consider both of these, two of these, as being one of this form and another integral of this form, since they are both equal to each other, these two copies of this integral can be written as this integral plus this integral, which if we write that down, we can see it's going to be equal to the integral of 0 to pi by 6 of cosine of x plus pi by 3 divided by sine of x plus cosine of x plus pi by 3, which is of course the first part of our integral, the first integral. But since we have two copies, the second copy I'm going to convert into this form, which means that is equal to plus the integral from 0 to pi by 6 of the sine of x divided by the sine of x plus the cosine of x plus pi by 3 with respect to x. Now considering these two integrals, since they're both integrated with respect to the same variable and they both have the same limits here, 0 to pi by 6 and 0 to pi by 6, we can see that these two are actually equal to a single integral from 0 to pi by 6 of the sum of the two terms on the inside, which is this term and this term. Since we can see they have a common denominator of sine of x plus cosine of x plus pi by 3, we have a common denominator of sine of x plus cosine of x plus pi by 3, and the numerator is also cosine of x plus pi by 3 plus sine of x, and we integrate that with respect to x. Now we can see, since this top is the same as the bottom, they will cancel out, leaving us with just a 1. The whole thing cancels here to this whole thing, leaving us with just the integral from 0 to pi by 6 with respect to x of 1 dx, which is simply the limits of the integral of 1, which is theta, or in this case x rather, from 0 to pi by 6. So now if we evaluate this, we can see when x is equal to pi by 6, this thing on the inside is going to be pi by 6, so we have pi by 6. And when x is equal to 0, we have 0, so that means we have minus 0, which is equal to pi by 6. Now note, this value of pi by 6 that we just obtained is 2 times I. So therefore, if we consider dividing both sides, we can see 2i is equal to pi by 6, which implies that I is equal to pi by 12, and hence if we consider what I is equal to up here, I is this integral, which is also this integral, and what we wanted to find is that integral's value. So therefore we can finally say as a final statement, we could leave it at this, but I would much rather write down the exact result that's given in the paper. So I'm going to write that the integral, therefore the integral from 0 to pi by 6, which is exactly I by the way, of cosine of x plus pi by 3 divided by sine of x plus the cosine of x plus pi by 3 integrated with respect to x is equal to pi by 12. And there we go. That is our final answer for that question, and that is all that we have for this question. Now finally, if we consider the marks awarded for this question, at the start, when you apply the formula that they gave, this formula right here, when you apply it and rewrite the integral as the integral from 0 to pi by 6 of all of this stuff, you get 10 marks right then and there. When you then realize that you can simplify some of this down, you can add this angle to this angle and so on and so forth, and you simplify down to this expression here, you get 5 marks. At this point after that, when you then use this trigonometric identity to substitute in some of these trigonometric values, as in the cosine of pi by 2 minus x as sine of x, and get to this point right here, you get 5 marks. And when you simplify it all down and you get the final answer of this integral here, the integral from 0 to pi by 6 of sine of x divided by sine of x plus cosine of x plus pi by 3 with respect to x, you get 5 marks. Now, for the second part of the question, when you then realize that if you consider 2y, you can break this component here into a component that is the original integral and the second component, which is the integral that we found previously, and then when you add them together and get this expression here and simplify down to this thing, you get 10 marks for breaking this integral into these two pieces, and then another 5 marks for simplifying it down until you get the integral of 0 up to pi by 6 of 1 dx, and then you simplify it down until you get pi by 6. Then finally, when you then rearrange to get that the integral I must be equal to pi by 12, and therefore the integral from 0 to pi by 6 of cosine of x plus pi by 3 divided by sine of x plus cosine of x plus pi by 3 with respect to x is equal to pi by 12, you get a final 5 marks. So that is going to be all for this question, and that is also going to be all for this video. I hope you enjoyed. If you have any feedback, post them in the comments down below. Thank you for watching, and goodbye.